The next term to be evaluated when determining contributions is the response to detected failures. Now, when a safety system is able to detect that a failure has occurred in a logic solver or a sensor subsystem specifically, you have the ability to change how you can respond. There are two choices. Number one, and let's look at a sensor. So if you detect that the sensor has failed, usually by the signal going off scale low or off scale high, you know that the device has failed and that you don't have a dangerous condition. So what do you do in response to that? Well, the default is the checkbox that says trip on detected failure. So in that case, the dangerous detected failures, or the DD term is what we're calculating now, would be 0 for probability of failure on demand, because there's a 0 amount of time that the device is in the failed state due to a dangerous detected failure and the process continues to operate. But that dangerous detected failure rate then gets converted into a spurious trip rate. So a dangerous detected failure will result in a plant shutdown when there was no actual demand that would cause the plant to shut down. So that's where that goes. But now, if instead I detect that a transmitter failure occurs and I program my logic solver to set an alarm indicating that the device has failed and needs to be fixed, but allow the plant to continue operation, perhaps using an alternate protection plan to ensure that it can still be done safely, I would uncheck that, because now we're not going to trip on detected failure. We're going to alarm and repair. So in that case, the dangerous detected failure is not converted into a spurious failure. It's going to be creating an unavailability of the safety instrumented system. And you'll see that Vertigo is trying to calculate the PFD associated with that, but in order to do that, we need to know something about the mean time to restore, which is going to include a diagnostic test interval. So we know from earlier that we have a mean time to repair of 72 hours, but we also need to know what's the amount of time that elapses between when the situation is detected, the failure is detected, and that failure is enunciated to the operator to begin the maintenance process. Now, for a logic solver or a sensor, that's probably going to be as small as one scan, maybe 100 or 200 milliseconds, maybe a second. So in comparison to the 72-hour test interval, that washes out to be approximately 0 in terms of the automatic diagnostic test interval. But if you were doing something like partial stroke testing that occurred weekly, that diagnostic test interval could be very long and important and drive the PFD associated with the dangerous detected failure mode. So in this case, if we were not tripping on a dangerous detected failure, we would then go ahead and calculate the contribution to PFD associated with dangerous detected failures.